Welcome back, everybody. Today we are going to talk about section 10.5, graphs of sine and cosine. Now that we know the unit circle and we're expert at getting those values, what we can do is we can utilize those values to create graphs of the sine function as well as the cosine function. Now, very often in our algebraic graphs, we did an XY table. We declared values for X, plugged them into our equation, got values for Y. For a trigonometric graph, theta is going to kind of be like our X. Now, theta is always going to be in radians. And then when we plug it into our equation, we'll come out with a Y. So very often what you're going to see is a chart like this where you'll have theta, and I'll put in values like 0, pi over 2, pi, 3 pi over 2, and 2 pi, something like that. You take those, you plug them into the equation, and the Y value comes out of it. All right, and it could be something like Y equals sine theta, Y equals to cosine theta. There's an infinite amount of equations that we can graph, not necessarily always using these points, but using a table. All right, for purposes of this lesson, we're going to graph one period of each function, and in this lesson we'll discuss what that means by a period. All right, so the first question is, how do I get really good graphs? Well, let's start with the most basic functions, all right? So let's start with y equals sine theta. Now, any value for theta on the unit circle in radians you can use. You can use 0, you can use pi over 6, you can use pi over 4, you can use pi over 3, you can use pi over 2, any of those values. So if you want to explore some of those values, you are certainly welcome to. When you run them through the equation, your resulting value, you can either call it y or you can call it f of x, whatever you want to call it, would potentially be a decimal. Now, a decimal is not a bad value. A decimal is a fine value, but we're graphing by hand, so you would very much have to estimate. So we're going to start with what I call the key values for the sine function. And those are 0, pi over 2, pi, 3 pi over 2, and 2 pi. And now what I'd like you to do is I'd like you to pause the video. I'd like you to input these values into your basic sine function and get your y values out of it. All right, we'll talk about the answer on the back end. All right, so if I take 0 and I plug it in, the sine of 0 is 0. The sine at pi over 2 is 1. The sine at pi is 0. The sine at 3 pi over 2 is negative 1. And the sine at 2 pi is 0. All right, so now that we have the xy values, we can then draw an axis and create our graph. I'm just going to do it right here on the side. Here's 0. All right. Remember, the x and the y-axis go in both directions. So this is pi over 2, pi, 3 pi. The reason we're using radian values is radian values are real numbers. Now, I know I'm using pi, but remember, pi is an irrational number, so we can't get an exact value for pi over 2, can't get exact value for pi. So we have to use this representation, all right? But it doesn't dissuade the fact that this is indeed a real number. If you want proof it's a real number, take your calculator, put in the pi symbol, divide it by 2. You will get you will get a very long decimal that even your calculator will round. All right, but our y values are going to be 1 and -1. And we start at 0, and then we go up to 1, then 0, then -1. All right, my drawing's not the best, but it works. And what you'll find is that if you chose any other value like pi over 3 or pi over 4, you would have a value along this curve. Now remember, you don't need every point to get your graph. I always say draw a sketch, meaning you need just enough points to get a good shape of your graph. All right, now I used a couple of terms that I would like to define. And the first is the period. All right. So the general form of the equation is y equals a sine bx. Now, different books will use different letters. I'm using just our regular English alphabet because it makes things a lot easier. But our amplitude equals the absolute value of A, and our period, which is the time it takes to repeat the graph. So write that down. Our amplitude is how high or low it goes. Our period is how the time it takes for the graph to repeat, is 2 pi over b. So if my graph is y equals sine x, a is 1, and we notice that our graph goes up 1 unit and down 1 unit. And our period is 2 pi over b, which is 1, so 2 pi. And we go up, then down, then up. And it looks like our graph is going to repeat from here. So if I graphed the period from 2 pi to 4 pi, it would look exactly the same as from 0 to 2 pi. All right. So let's start changing this graph around a little bit. So let's do an example. Y equals 3 sine x. So what this means is that my amplitude is 3 units. Now my period is still 2 pi. And again, we're only going to graph one period. All right, so I have theta, or in this case I used x, so I'll do an xy table. And again, we're going to use the same values we used before. 0, pi over 2, pi, 3 pi over 2, and 2 pi. All right, they're not going to change for this particular example. What I'd like you to do at this point, pause the video, run each one of our x values through our equation, and get me some y values. And we'll talk about the answer on the back end. All right, so again, we plug 0 in. Sine of 0 is 0, times 3 is still 0. Plug in pi over 2. Sine at pi over 2 is 1. Times 3 gives you 3. Then the sine at pi is 0. Times 3 still gives you 0. Let's put in 3 pi over 2. Sine at 3 pi over 2 is -1. Times 3 is -3. And then 2 pi goes back to 0. The plugging in the chart shouldn't be the hardest part of this. So let's again, we're going to make our one period. Oh, these aren't evenly spaced. Let's try to make them a little bit better than that. 2, 3, 4. So that's pi over 2, pi, 3 pi over 2, and 2 pi. And instead of going up 1 and down 1, we're going up 3 and down 3. So I got there, 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 and there. And what we see is that those key values still seem to be getting us nice, pleasant numbers. I am very much in favor of putting arrows on either end of this graph. It is important that you know that this graph continues. That if you wanted to, if you were asked to make a graph of 2 periods, that you could make a graph of 2 periods, or you could make a graph of 3 periods. You could go from negative pi or negative 2 pi to positive 2 pi. You could go from negative pi to positive pi. You could make a period or 2 periods or 3 periods at any values. All right, so let's kick it up a notch. Try another example. And again, I'm going to give you a variety of different examples to give you some experience. I simply can't give you all the examples, so you're going to have to do a lot of practice on your own. Y equals negative sine 2x. So let's start with our period is 2 pi. Now b is 2 in this case, so it's 2 pi over 2 or pi. And our amplitude equals, now it's negative 1 in front, but remember our amplitude is the absolute value of a, so our amplitude is 1, right? The absolute value of a is 1. All right, so how, now our period has been adjusted. It's been adjusted from 2 pi to pi. So our x values of 0, pi over 2, pi, 3 pi over 2, and 2 pi, that was one period when the period was 2 pi. Now, basically, we're cutting everything in half. So our new x values basically have to be, take our old x values and just cut them all in half. So 0, cutting it in half would be pi over 4, then pi over 2, then 3 pi over 4, and 2 pi. So we're going to use our x new, and we're going to plug them into the equation and get out a y. Now that we've used, right, now these are gone, right? We've already used them, so we can cross them off. If you want to, you can, if it helps. You're going to take your x value, your new x value, plug it into the equation, and get out a y value. So at this point, again, I'd love for you to pause the video and run those numbers and get me the y column. I'll give you the answer on the back end. All right, hopefully you ran the numbers. I got 0, -1, 0, 1, and 0. And now we're going to use our x new, right? Our middle, our x values that we ran through the equation, and our y values in order to make a graph. All right, so I'm going to, well, I'm going to have to scroll up, but we can deal with that. So, all right, so our x values are going to be 0, pi over 4, pi over 2, 3 pi over 4, and pi. And then our graph now, right, that negative in front means instead of going up, I'm going to be going down. So it's going to be reflected. So down, then come up. And these values are all on your chart. So definitely consult your chart. Make your graph. And it should look something like that. The better drawers will make better graphs. Your graph needs to be mathematically accurate versus drawn nicely. All right. So that's the way to use your key values to your advantage. Those key values are very handy, whether the period changes or it shifts left or shifts right, as we'll see later. those key values are a great place to start. Now, you won't always use them as your X column, but I like making the adjustments by having a good place to start. All right? But we got to get into cosine now, because we said this was graphs of sine and cosine. So the key values for cosine are the same as sine. So again, they're going to be zero, pi over 2, pi, 3 pi over 2, and 2 pi. The key values for the other trig functions, the tangent, cotangent, secant, cosecant, will be different. But for sine and cosine, they have the same key values, makes things a whole lot easier. Now we're going to start again going into some more advanced functions, but we're going to use the cosine function. All right, so let's try our next example, which would be f of x equals 2 cosine 3x. All right, so the first thing I want to know is, what is my amplitude, what is my period? All right, so why don't you pause the video, take a moment, find the amplitude and period, then hit play. We'll make sure that we're on the same page. All right, hopefully you hit pause. I got the amplitude to be 2 and the period to be 2 pi, and we're dividing by 3, so it's 2 pi over 3. And now we're going to do the same exact thing we did with the last example we did, which was that we had x values, which are 0, pi over 2, pi, 3 pi over 2, and 2 pi. And then we had x new. The reason we have x new is our period got adjusted. So all of our key values have to get adjusted to reflect the new period. So we're going to divide we divided our period by 3. We're going to divide our key values by 3. So I get 0, I get pi over 6, I get pi over 3, I get pi over 2 when I simplify, and 2 pi over 3. You are certainly welcome to check my work. Please leave a comment if I ever make a calculation error, or you believe I did. Now we need to know what f of x is, and here's where I'm going to ask you to pause the video. What you're going to do is you're going to take that middle column, right? This column is now gone. You're going to take that middle column, you're going to take your x values, put them back into the equation, and get me a value for y, or get me a value for f of x. All right, so at this point, pause the video, get those numbers for me. We'll talk about the answers on the back end. All right, hopefully you ran the numbers. I got 2, 0, -2, 0, and 2. And now we're going to take our x values and put them on the x-axis and find the corresponding point on the y-axis to plot our points. And then we are going to make our graph. Try to make it over here. So I'm going to go up 2, and I'm going to go down -2. Here is 0. Pi over 6. Pi over 3. Pi over 2. 2 pi over 3. All right. And we are going to start at 2. We're going to go down to 0. And then we're going to go down to -2, then 0, then 2. And again, I put the arrows to just remind myself that the graphs will go on and on and on. All right. So here's the kind of example you could get that doesn't necessarily require you making a graph. And it reads like this. Determine the amplitude and period of the function. All right, so all we're doing is determining the amplitude and the period. So y equals -4 cosine 3x. So the absolute value of a, it's a terrible absolute value mark, equals 4. So there's our amplitude. And our period equals 2 pi over b. So it's 2 pi over 3, which is our period. And again, with no graphing, it tests your knowledge of the concept, but it takes a little bit less time. All right, so let's try to take this to the next level and see how we do. All right, so here is a potentially our last example. Y equals 5 sine x minus pi over 2. Now, we already know that our amplitude equals 5, right? We're okay with that. However, we now have something new here. We have a parentheses with minus pi over 2. This right here. This is new. We haven't done one like this in this video just yet. And what is that going to do? From our knowledge of transformations, that is going to shift our graph pi over 2 units. Remember, pi over 2 is a number. It's 1.5 something. Pi over 2 units to the right. All right. So now, how does that affect our x values? Well, let's start with our standard key values, which is 0, pi over 2, pi, 3 pi over 2, and 2 pi. Well, if everything has been shifted pi over 2 units to the right, we need some new x values, right? So what are we going to do in order to make an allowance for our shift to the right? Well, I'm going to take my old x value, and if it's shifted right, that means I'm adding to it. So I'm going to add pi over 2 to every x value to get a new x value. So I'm going to start at pi over 2. Then I'm going to go to pi. Then 3 pi over 2. Then 2 pi. Then 5 pi over 2. Now, you're going to take the new x values and run them through the equation. When you run them through the equation, you will get y values. All right? So take a moment, run them through the equation, and we'll talk about them on the back end. All right, so if I put pi over 2 in, pi over 2 minus pi over 2 is 0, so the sine of 0 is 0. If I put in pi, pi minus pi over 2 is pi over 2. The sine at pi over 2 is 1 times 5 is 5. Now I'm going to put in 3 pi over 2. 3 pi over 2 minus pi over 2 is pi. The sine at pi is 0, so that's still going to be 0. Now I'm going to do 2 pi. 2 pi minus pi over 2 is 3 pi over 2. The sine of 3 pi over 2 is -1 times 5 is -5. And put in 5 pi over 2 minus pi over 2 is 2 pi. The sine at 2 pi is 0 times 5 still gives you 0. And then you could graph these from here. All right. One last thing that I want to jump in with, and that is, what if I change the example? If I change the example to y equals 5 sine x, that's a terrible plus. I'm just going to say x plus pi over 2. All right, this is a graph that is shifted pi over 2 units to the left now. So if we're shifting the graph left, then we're going to take our x values, and I'm just going to get the x new of 0, pi over 2, pi, and 2 pi. And if I'm shifting pi over 2 units to the left, my x new would be pi over 2 units less than the original key value. So that would be negative pi over 2, 0, pi over 2, pi, and 3 pi over 2. And then, of course, you would do the same thing that you did before, which is take your x new, your new x value, run them through the equation to get your, your y value. All right. Again, I can't, there are so many different examples. I definitely encourage more practice. More things will come up, but these are the fairly standard basic things you need to know when graphing trig functions. Thank you guys for listening, and I'll see you guys next time.